So what would actually happen if you fell into a black hole? I mean, really. We're about to take a little trip to a place where the very fabric of reality just unravels. We're going to find out what physics says about the ultimate one-way journey.
Okay, just picture it. You're floating out there in the deep, silent dark. All around you are those familiar, beautiful pinpricks of distant stars. It's quiet. It's vast. But then, something starts to feel off. The light from the stars around you, it begins to bend. It's distorting, like you're looking at the universe through a giant cosmic lens. You're being pulled towards something you can't even see. You're falling toward a black hole.
So, what's the real story here? Let's forget all this sci-fi movie stuff for a minute. What does actual physics say would happen to your body and to your sense of time on this insane one-way trip? All right, first things first, we have to approach the beast. This is the part of the journey where the rules of physics are still kind of familiar, but the danger is ramping up with every single foot we get closer. Now, before we go any further, let's just bust a few myths. Black holes are not cosmic vacuum cleaners. They're not just roaming around the universe gobbling everything up. In fact, and this is wild, if our sun were to suddenly be replaced by a black hole of the exact same mass, we'd be fine. Earth would just keep orbiting like nothing ever happened. See, gravity is gravity. The whole thing, the real danger, it all comes down to one word: proximity. The danger isn't that the black hole exists. It's about crossing that invisible line where its gravitational pull becomes, well, totally overwhelming and absolute. As you get closer, you'd start to see something that should be totally impossible: a brilliant, glowing ring of trapped starlight. This is the photon sphere, a place where gravity is so intense that it forces light itself to orbit the black hole. You're literally seeing stars that are behind it, their light bent all the way around for you to see. It's the first real clue that the geometry of space itself is starting to break. And just past that glowing ring is maybe the most famous boundary in the entire cosmos: the event horizon. Now, this isn't a physical wall you could touch or anything. It's a threshold. It's a point in space-time. It's the ultimate point of no return. The second you cross it, every possible path you can take, every direction, points to one place: the center. And this is where things get really, really weird, thanks to Einstein's relativity. For a friend watching you from a safe distance, you'd look like you're slowing down as you get closer to the horizon. You'd seem to freeze, stuck in place, and then just slowly fade from view over what to them seems like forever. But for you, your experience is completely different. You don't feel a thing, no barrier, no jolt. Time feels perfectly normal as you fall straight on through. Because once you pass that event horizon, the laws of physics stop being some abstract idea. Oh no, they start to get very, very personal. And I'm not kidding, that's the actual scientific term for it: spaghettification. It might sound a little silly, but trust me, the process it describes is absolutely terrifying. This is what a black hole's gravity does to anything that gets too close. So how does this even happen? Well, imagine you're falling in feet first. The force of gravity pulling on your feet is way, way stronger than the gravity pulling on your head. This difference in force is called a tidal force. It's the same thing that causes ocean tides on Earth, but just magnified by trillions. It literally grabs you and just stretches you, longer and thinner, like a piece of spaghetti, until you're pulled apart into a literal stream of individual atoms. Okay, so your physical body has been, let's say, rearranged. But what about your perception of reality itself? This is where things get even stranger, if you can believe it. That immense gravity doesn't just warp space, it fundamentally warps time itself. It's this phenomenon called gravitational time dilation. As you fall deeper and deeper, time for you slows way down compared to the outside universe. So for every single minute that passes on your watch, hundreds, thousands, maybe millions of years could be flashing by for everyone and everything else. And the consequence of that is just staggering. You are, in a very real sense, a time traveler. You're falling into the future, watching the entire cosmos age at an unbelievable speed from your front row seat to oblivion. So you've been spaghettified. You've watched eons flash by in the blink of an eye. So what's next? What is at the very, very end of this line? At the very heart of it all is the singularity, a single point with literally zero size and infinite density. And here,
Well, here's where our science just stops. All of our equations, everything we know from general relativity to quantum mechanics, they just break down. We have no idea what happens here. It is a complete and total mystery. So after that pretty terrifying journey into oblivion, it's really easy to think of black holes as just these cosmic monsters, right? But that's not the whole story. Not even close. If we zoom out a bit, we see they actually play a very different role in the universe. Far from just being destroyers, black holes are more like architects. The supermassive one at the center of our own Milky Way, it acts like a gravitational anchor, shaping our entire galaxy. Some theories even suggest that their intense energy can trigger the formation of new stars. They are these unbelievably powerful cosmic engines of both destruction and creation. So it turns out their destructive power is also a creative one. It's all part of this grand cosmic cycle of death and rebirth. They're violent, for sure, but they are also absolutely essential architects of the universe as we know it. You know, this whole journey into a black hole really reminds us of a profound and, frankly, a very humbling truth. Our intuition, our day-to-day sense of how things are supposed to work, it just completely fails when you get to extremes like this. When you really think about these places where reality itself just bends and breaks, it makes our own existence, right here, on this quiet, stable little planet, orbiting a very normal star, seem that much more precious. And maybe, just maybe, the most profound miracle of all.